In this session, we're going to write a proof for the derivative of the sine function, the sine trigonometric function. And the derivative of sine with respect to x is cosine of x. And to see this graphically, we can think of this from a slope perspective. If this is sine, think of the derivative as the slope of the tangent line of the function. And you can see that the slope of the tangent line here is going to be positive, and in fact the slope of the tangent function here is 1. So cosine starts out at 1. And as we move along, the slope of the tangent line is flattening to this point where the slope of the tangent line is 0. So that means cosine is moving down to 0 at this point. Here, the slope of the tangent line is decreasing to the point where here the slope of the tangent line is -1. So the function is decreasing to this. And then again it flattens out and it goes to 0 at this point again. And then the slope of the tangent line is becoming more positive here. So it goes here. So you can see from an empirical standpoint, graphically, that the derivative of sine is cosine. So let's go ahead and do this analytically. And like we did in many of our other proofs, we're going to use the limit definition of derivative to do this. So the limit as delta x approaches 0 of sine x plus delta x minus sine x all over delta x. Now, what we're going to do at this point is to expand this expression using the sum identity for sine. So, sine of x plus delta x is sine x cosine delta x plus sine delta x cosine x. And then we add in the last piece, minus sine x, and that's all over delta x. So now we're going to do a little regrouping of our terms, and I want to move this term over to be to the right of this term. So let's do sine x cos delta x minus sine x plus sine x, actually that's sine delta x cos x, and that's all over delta x Okay, now in this expression we can factor out a sine x, so we have sine x times cos delta x minus 1 plus sine delta x cos x. Forgot the parenthesis here. And that's, again, all over delta x. Okay, let's give ourselves a little bit more room here. And we're going to pull down, this limit down to here. And I want to regroup these terms because embedded inside here, you may not be able to see it yet, but there's a couple of special limits that we have looked at in our study on limits. That the first thing I'm going to do is I'm going to factor out a -1 out of this to rearrange these terms. So what I'm going to have is negative sine x, and this is going to be 1 minus cosine of delta x plus, here we have the same sine delta x cosine x, and this delta x is under every one of these, so I'm going to put that under this piece just to make it a little more evident of what's going on, and I'm going to put the delta x under this piece. This is just a visual representation. Of course, this delta x is under both of them, but you can see here that what we're going to have is the limit as delta x approaches 0 of this quantity. Well, this is a special limit. The limit as, that's supposed to be an x, the limit as delta x of 1 minus cos x over cos delta x over delta x, this is a special limit that goes to 0. And this is a special limit, the limit as x approaches 0 of sine x over x is 1. So this limit goes to 0, this limit goes to 1, and that leaves us with, this goes to 0, this goes to 1, and if we take the limit as delta x approaches 0 of this entire expression goes away, and we're left with cosine of x, because the limit as delta x approaches 0 of cosine of x is still cosine of x because there's no delta x term here. So the result here, very peculiar, cosine of x. And there we have the proof of the derivative of sine. So the derivative of sine is cosine. And I will see you in the next session.